All right, let's take a look at this one. We can do this one actually without doing any math if we wanted to, because the numbers are nice and round. So we have two samples, A and B, and we want to figure out, and they're both sodium hydroxide samples. So we have sample A and we have sample B. And what do we know? Now they're both sodium hydroxide samples, and we know if we have 10 milliliters of A, then we have 10 milliliters of B. Okay? And what do we do with those? Well, 10 milliliters of A required 22 milliliters of 0.1 molar HCl to neutralize that. So we have 22 milliliters of 0.1 molar HCl. And sample B required, let's see, to neutralize required, what did it require? 10 milliliters, I'm sorry, 48 milliliters. So 10 milliliters of solution B required 48 milliliters of 10th molar HCl. Okay, so to neutralize. Now, remember, the reaction between HCl and sodium hydroxide is 1 to 1. So if I'm looking at this, I know that NaOH plus HCl produces, what does it produce? A salt, sodium chloride, and water. It's all balanced up, sodium, sodium, chlorine, chlorine, two H's, and O, and O. Okay, so that's a balanced equation. Notice it's a 1 to 1 mole ratio. So for every mole of HCl we add, we're going to react with a mole of sodium hydroxide. So now it took 22 milliliters of this HCl solution to neutralize A. So that means that if we figure out how many moles of HCl that we added, that's how many moles of NaOH are in these solutions. Because remember, these are sodium hydroxide solutions. So if we look at the same thing for B, B required 48 milliliters of this 10th molar HCl solution. So it required more of the same concentration solution. So what does that tell us? Well, it tells us that the fact that A only required 22 milliliters to neutralize it, but B required 48 milliliters to neutralize. That means that there were more moles of HCl added to B than to A, which means that there are more moles of sodium hydroxide in B to begin with. Okay. So what that means is, since the volume of each of these solutions was the same, they're both 10 milliliters, and there are more moles of NaOH in B than in A, then that means that the concentration of B is greater than that of A. So the conclusion that we can draw then in our answer is that the concentration of sodium hydroxide in B is greater than the concentration of sodium hydroxide in A. There you have it.